This conference will now be recorded.
7+ years of exclusive experience in the solar photovoltaic field as a director, technical operations at Vatio Energy India Private Limited, Chennai, and working as Chief Technical Officer at Tamil Nadu Advanced Technical Training Institute, Chennai. He holds an electrical engineering degree from Anna University. After graduation, he started his career at BHEL Corporate Research and Development Center as a research associate, later moving into the academic sector and then turned to be a solar technocrat. Having strong knowledge in the field of solar energy, he has a vast experience in the project management, technical operations, and capacity building and human resource development involved in the solar photovoltaic integrations. He has the following work experience and recognitions. He is a consultant, master trainer for the National Institute of Solar Energy, NISC, consultant for SCT, NET, Solar Energy Training Network programs, also the training director of PATTI for Suryamitra, the solar technician training program sponsored by NISC. He conducted many skill development initiatives like skill orientation and induction programs, content preparation, and publishing of book materials. He has delivered around 45 lectures, guest lectures in various colleges and universities. He has developed curriculum and course material for different institutes and published a book on the Handbook of Solar Photovoltaic Technologies, and it is highly preferred by PV academicians, writing 2 books on solar energy sector for National Instructional Media Institute, NIMI. He is appointed as the industry advisor member for curriculum and content framework by different educational institutions in India. The flagship training programs organized by him are as follows. Training Director for Suryan and Konark Solar Training under SCT NET. Program Implementation Director for Suryamitra Solar Training under NISC and PATTI. Training Director for Solar Training Programs under SCGJ at PATTI. Training Director for MANAS Solar Training Programs under Minority Minister. Now about his professional accomplishments. Certified Solar Photovoltaic Engineer from the Entrepreneurship Development Institute, Government of Tamil Nadu. Certified Solar PV Trainer from National Institute of Solar Energy, NISC, Government of India, and USAID SCT NET for solar training programs. Certified Solar PV Master Trainer from Skill Council for Green Jobs, NSDC for 9 qualification packs, and Master Training Solar Photovoltaics, Tamil Nadu, Advanced Technical Training Institute, PATTI, President of National Association for Renewable Energy and Research, Academic Advisory Committee member of 3 University and Allied Educational Institute in Tamil Nadu, Technical Resource Person for Entrepreneurship Development Institute, Chennai, and Directorate of Technical Education, Chennai, Best Tester and Host Developer of Solar Pro and Photovoltaic Simulation Software in India. Till now, he has guided 30 project works, 6 research projects, and done 12 consultancy projects. He has published papers in 15 national conferences, 5 international conferences, and done 10 project demonstrations. We are very happy to welcome you, sir. Now I am handing the session to the speaker.
Thank you, Dr. Uma, for inviting me.
Thank you, sir.
Sir, I'll make it as a presenter, sir, now.
Yeah, shall I start?
1 second, sir. I'll make you as presenter, sir.
Okay.
Yes, sir. Now you are the presenter, sir. You can share your slides, sir.
All right. Dr. Uma, this presentation is visible for you all?
Yes, sir. Yes, sir.
All right. So shall we start the session?
Yes, sir.
Okay. Very good afternoon, everybody who came for this webinar on energy management implementation techniques and energy conservation best practices. I first like to thank the management of RMD and Dr. Tamil Selvi and Uma Bageshwari and other facilitators who is organizing this program. As being in the lockdown, everyone is trying to learn something, do something, and trying to upskill their things. At the outset, the conduction of this kind of FDP program to the relevant industry needs or the current hot topics is really appreciated. And as a part of my side, I just want to share a few of the industry knowledge, experiences which we gained in our own respective sectors to the academicians. I strongly feel that any industry will become success only if there is a proper bridge between the industry and academia. That's why we used to call it as an III, that is Industry Institute Interaction. Many of the colleges might have one cell called III cell, but I don't know how many of them are effectively implementing that. But I strongly feel that if the industry institute interaction is better, then definitely the outcome of the students, the knowledge of the outcoming students, and also the kind of the projects research they are doing will definitely meet the industry standards. In continuation to that, I just want to put something about the very important topic, which is the energy management. We all used to say that we are in deficit of energy. We need energy. Our energy demands are keep on increasing. But do you think if you have a demand and going for the generation keep on increasing is not at all a solution? I always used to say one thing: before think about energy generation, think about energy conservation and optimal utilization. If we start using the energy systems, if you start managing the energy things in a very optimized way, very intelligent way, very efficiently, then definitely the demand for energy generation at the whole outline, you can see it will be very drastically reduced. Because instead of thinking of generation, first think, are we utilizing the power properly? Are we saving the power which is not at all actually has to be wasted? So this complete webinar is going to talk about the energy management and how it can be implemented, and how the energy conservation practices can be followed. So this is the main objective and main outline of the webinar. Coming to the main issue, the world is facing a biggest threat, that is the climate change. The climate change has very serious impacts in different sectors. The global warming, greenhouse gas emissions, an increase in temperature, and deterioration of natural resources, fossil fuels, water resources, contamination of soils, air quality index. So all these factors are heavily affected only because of the usage of energy in different forms. As you know that energy can neither be created nor be destroyed, but it can be transformed from one point to another, one form to another form. So since it cannot be created and cannot be destroyed, one must know how to manage it. One must know how to control it. One must know how to handle it. So we are going to see in a very brief manner about today. Let's go into the presentation. Okay, let's see what is energy management. Energy management is a system of computer-aided tools with the operators of the utility grid to maintain, monitor, control, or optimize the performance of generation or a transmission system. I'm just give an example, simple example for your understanding. Everyone will be having a fridge in your home. The fridge will be running 24/7 into 365 days. But we never done a practice of assessing what is the kind of energy the fridge is consuming. We have not done this so far. Why? Because we all think yes, the fridge is running, my application is met, so I'm not worrying about it. But if you go and look into the energy consumption pattern of a device which is running for a long time, or the nature of supply coming to the load is having kind of an harmonics or any kind of disturbances, definitely the fridge, the load will not consume the exact power of what it is supposed to consume. So if a fridge has been given a wattage of 200 watts, it may not be consuming 200 watts by that time. It may be consuming 200 or 220 or 225, sometimes even it may more. So everywhere, slowly, small kind of power has been utilized, consumed invisibly. So those power is actually the very dangerous factors for energy management system. Through the energy management system, we are going to monitor the entire system. We are going to identify what are the kind of losses, what are the kind of leakages, what are the kind of unutilizations, overutilizations happening in the system, and we are going to prevent it. We are going to control it, and by which ways we are going to increase the efficiency of the system and reduce the cost of that. Now, why to manage energy? So energy management is the key to save energy. Basically, in an organization, let's take your home as an example. Every 2 months you will be getting in your electricity bill. If your electricity bill is 1,000 rupees, you will be yes, okay. If your electricity bill is 4,000 rupees, you will see, oh, 4,000 rupees. If your electricity bill is 10,000 rupees, then you say, God, what is this? Why I'm getting 10,000 rupees as a bill? What happened? Then you will shout at your peoples in your home. You will shut off your ACs. You will shut off your all these things. But what this is not the solution of energy consumption. This basically we need to think how to manage that situation, how to prepare an alternate for it. So the main importance of energy management system is basically to the impact. If you miss to focus on the energy management, you will be end up in high kind of energy rates you will be paying to the discoms, because the energy prices have been increasing, and there are a lot of emissions which is going into this, and policy wise also it's keep on changing. So basically an organization should be very keen on how to save the energy in every means possible. And second thing is how to reduce the dependability on fossil fuels become increasingly limited in supply. Why? Because as long as you have coal, you have lignite under the earth, will be taking up. But there will be a point, because it is not a renewable source, it is not a perennial source. It is a non-renewable source. Once you take that, it will not come, it will not replenish. So the management of energy, bringing the alternate energy forms, will definitely make us to reduce our dependability on fossil fuels, so that we give some of the fossil fuels to our future kind. Otherwise, in the next 10-15 years, we'll be end up in completely deploying, completely utilizing the fossil fuels in the earth, and the future of our next generation will be a big question mark. It is we can call it as practically the energy management can be done by means of metering and collecting the data of energy. Metering is nothing but just record its consumption. For example, today what is the consumption, tomorrow what is the consumption, what is the average consumption per day, what is the average consumption per week, what is the average consumption per month, what is the average consumption per year. So if you have the data of those particular load and the sequential data of the consecutive years, will make you to understand what is the wrong which is going in your system and how to overcome that. And also it leads you to find the opportunity and implementation methodologies to find how to save the energy. Usually, as an example, I say before 20 years, 25 years, we all have a incandescent lamp in our bulb in our home. That time the light will consume 60 watt, 90 watt, even some bulbs will be 100 watts. Those days we found that that is the only light we are supposed to use, and that is in the yellow color. and later days CFL come into the picture, the CFL will drastically reduce. It took the energy to somewhere around 20, 25 watts, 28 watts, 18 watts, like that. Later, the technology, the implementation method further improved, and we gone to the LED. The LED is now everyone can easily put a 5 watt, 7 watt, 9 watt that can very well support your lighting necessity for a living room. So you just think a 60 watt light has been taken drastically to a 10 watt LED is a very phenomenal kind of improvement, a phenomenal kind of energy efficient energy management that we have adopted, and in which ways we have actually conserving the energy. And the second thing, analysis and tracking of meter. So as I told, the keep track of record, like how you evaluate a student, uh, what is the mark he obtained in the assignment, what is the mark he obtained in the internals, what he obtained in the model test, like that. It will, so those data will make you to assess whether the candidate is going in a right path or is in improving phase or not. Similarly, if you take any load, you need to make the track record of the particular load, so you can come to a conclusion whether the performance of the particular product is in a very positive sign or it is in the deteriorating stage. If you calculate your efficiency of an electrical machine on the first year is 98%, for example, in the second year if you are accounting for 95, the third year you are accounting for 92, and the fourth year suddenly you are accounting for 75% efficiency, definitely you need to look into that system. How you know that the system is not performing up to the mark? You will only come to know by means of doing only the metering, tracking, and analysis of the data. So basically, an energy management system is deploying the measurement devices, deploying the accountability mechanisms in each and every part where you feel it has to be monitored. And this not only monitor the data, it will collect the data, it will store the data, and you will be analyzing at the back end, compare the data, analyze which is the higher value, which is the lower value, what is the average value, what is its consumption, how it can be, what is the kind of savings we are incurring about that, what is the kind of cost increase happening because of that. So everything has to be counted. Let's see the benefits of energy management, why we need to go for energy management and what are the benefits. First is if you go for an energy management system, we'll end up in a cost effective solution as a whole process in terms of the long run. Imagine, since I'm from a solar background, I'm just giving an example. If you are having a load of 500 watts in your home, which is having a normal fan, normal ceiling fan, normal tube light, a fluorescent tube light, and normal loads, it's not an energy efficient devices. In that way, if you calculate, if your total consumption of load is 500 watts, then imagine that customer is planning to put a solar plant for his 500 watt load. For that, we need to prepare a 500 watt load. We need to prepare an estimate, or we are supposed to install a 500 watt solar power plant, which cost approximately, let's say, 60,000 rupees. The next comes the implementation of energy management, energy efficient devices. So I'm suggesting a consumer to just replace the existing tube lights with new LED tube lights, which is going to consume only 18 watt. And I'm going to replace the existing fan, which is consuming 65 watt. Instead of that 65 watt fan, I'm just going to put a 24 watts, 28 watt BLDC fan as my ceiling fan. Like you can find the super fans and all this kind of stuff. By means of just replacing this, I'm drastically reducing my load 50% of my previous thing. So now imagine, instead of 500 watt load, I'm just going to calculate my system design only for a 250 watt. So now the cost of solar plant supposed to be there will be around only 30 to 35,000 rupees. Imagine, the purpose is met, the objective is obtained, the purpose is fulfilled, the lights have been given, backup powers is also ensured, but the capital cost of this particular purpose has been reduced from 60,000 to 30 to 35,000 rupees. So this is a simple example of the energy efficient energy management system and energy efficient techniques which we are supposed to follow in our premises. Like that, this is a simple example for a home. Like that, a big factory has to be taken, a big kitchen has to be taken, a big educational academic institution has to be taken, a big factory, manufacturing industries, processing industries, storage industries. Everyone has to look into that. It's not about only the lighting, it's not only about the fan, it's completely about the heating, it's completely about the cooling, it's completely about the ventilation, preheating applications. Everything comes into the picture. I'll give one more example about how to manage the energy. And this is also this one thing which I given in the solar photovoltaic background. The next thing which I give is the solar thermal background. Imagine in all the big kitchens, in all the big processing industries, you need a hot water majorly. And if you take any industry, the major consumer of power is the geysers or the furnaces or the
Yeah.
heaters, which effectively heat 40% of the energy consumption. So imagine you are bringing a solar thermal system into the design, and the hot water which is required for the process is being heated by a solar heater, which means the water is not going as a at a room temperature and it is further increased with a heating element, which is already going as a hot water because it is preheated. By just doing this process, you will end up in saving 30 to 40% of your energy consumption by the heat chamber we is supposed to heat the water. So this is one simple example of how the energy can be managed. Energy utilization can be very well managed. Then the benefit is reducing the risk, because if you keep on increasing on your load, actually energy, you will be under risk. One is your demand risk, second is your cost, third thing your future extension cost. Everything is a risk if you keep on increasing. Then the next is the reduction of carbon emission. Imagine a 1 kilowatt of solar power plant will effectively can eliminate 600 kilogram of carbon emission into the atmosphere. In this case, if I am not putting an energy efficient system, energy management system into my application, example, I'll be using a 2 kilowatt of power on an average every day for example, 8 units per day. Instead, I'm using an energy efficient devices. I'm bringing the energy management system into the practice, by which ways I will be end up in utilizing only 4 to 5 units. So imagine on an year, by simple means of implementation of this system alone, will reduce the carbon footprint of about 500 kg per year. So you just impact the impact of a 4 units to 5 units per day consumption will have on an annual, if you calculate, you will end up in eliminating 500 to 600 kilogram 500 to 600 kilogram of carbon emission into the atmosphere, which is a very huge contribution by a normal house consumer. Then second thing, by bringing it to the energy management practices, there won't be any human errors. You may find the EB substation and all the places where the electrical maintenance people will be there. So they have a track record, they have a track paper in that. They need to practically go there, measure the data every 10 minutes, every 15 minutes, they need to write. Do you think 100% they are efficiently performing that task? If you ask the question, the answer will not be 100% yes. Definitely, there will be some manipulations, there will be some adjustment, there will be some round-offs, which may not be giving the exact situation, exact figure of what is happening in the site. So, employing the system in the right places, collecting the data, avoiding the manual accounting process will definitely increase the efficiency and accuracy of the data you recorded. And second thing, if you have all data in place, it is very easy to configure and maintain. Just think that you have all data in your cloud server, and that data can be accessed by any person who belongs to that. It is very easy. But instead of having something in the paper, and if I ask, you need to send that paper by a photo or just by a Xerox copy, and again someone has to again refigure it into the computer system. It is all a laborious process. So this is one advantage. Then next helps to identify the inefficient electrical equipments. As I already told, any device has to be checked, inspected with voltage, current, power factor, frequency, harmonics. If you observe the 5 kind of behaviors in a particular load, you know what is the actual performance of the system, and you know what is the device is supposed to perform. The difference of these two things is your error. So look into which factor it is getting affected and try to locate on that particular part, try to replace with the countermeasures, and the problem will be solved. Energy efficiency will increase. The next is the important thing is the maximum power demand analysis. Many of the industrial consumers, they'll be using the loads, which sometimes they may go for a higher production. They may not know what is the kind of demand which they are experiencing, but in the electricity bill when they get, they will be put on a penalty. When he go and ask, then the EB person will say you have consumed more power than your limit. Then how the consumer will know he is exceeding his demand? Most of the not every consumer is an electrical engineer. Not every consumer knows the fundamentals of electricity. So basically, if you employ a system to manage it and just intimate or just give a buzzer or just kind of an information to the guy stating that you are exceeding the power demand, so reduce your load, which eventually reduce the penalty on maximum demand consumption. Then this is the further bifurcation of direct benefits and indirect benefits. You can just have a look on this, like it involves like cost saving, then reduction of footprints, greenhouse emissions, reducing the dependability of fossil fuels, and also like every state government has their SLDC, which you call it as a state load dispatch center. So if you take an example, at 5 megawatt solar power plant and utility scale power plant is there, which has to be given a data to SLDC, state load dispatch center, one day in advance to tell them this is my kind of expected energy generation for tomorrow. Based on your input, SLDC will plan the grid network, maintain the loads. If they want to add any cogeneration plants, they will add. They want to remove any generation plant, they will remove. Do you think how this kind of process, this kind of practice is possible? Only if you know what is the kind of generation happening from the plant on every day, on every minute, on then basically on with that particular data and with simulation tools along with the irradiation data and the temperature and all these stuffs, we can able to come to a conclusion on the basis of computation. Yes, tomorrow my generation will be this much. Based on that, the SLDC can plan the things. So this can reduce the uncertainty of the load shedding. This can reduce the uncertainty of energy overshoots and blackouts. Then indirect benefits, these are the indirect benefits. It will increase the operational efficiencies, and as an organization, your maintenance practice should keep on increase. And third thing is safety and health. Imagine if your motor is not working at a good efficiency, if you're not been intimated, the guy who is working with the motor or the kind of process, let's say it is a CNC machine or it is doing some performance where a humankind is near to that, if the motor is not performing to its operation, definitely it may burn out, or that malfunction of the machine will lead to some kind of human fatality also. So maintaining the system, monitoring the system definitely will improve our safety and health of the environment. Then let's see what are the steps to be taken to implement. First is the self-assessment. We need to know what we are, what is happening with us, what is the kind of consumption we have, what is the kind of demand we have. All the self-assessment has to be taken. Then next, build a business case. So just plan how can our energy management system can be implemented. What is the cost which is incurred? I'm just giving an example. If you think investing my cost, I'm again taking your domestic as an example. You are having a normal fan and normal light, and the normal fan and normal light will be consuming 65 watt, 70 watt, and the light will be 40 watt, tube light will be. It is consuming this power. So totally it is 110 watts, let's say. I'm recommending you, please remove those two, I mean the light and fan. Please bring up a new LED and a DC fan, BLDC fan. In this case, fan will be 30 watt and light will be 20 watt. So totally 50 watt. So 50 watt I'm saving. I'm just telling you you buy a new fan and light. The customer will ask me, no, I can't invest on a new product. So in that case, how you will make them justifiable? So just do an cost analysis. If you consume 100 watts of load for 365 days, how much you will be consuming? What is the cost you are paying? Case 2, calculate after implementing this new light and fan, the energy efficient devices, what is the kind of energy consumption you are having, what is the cost you are paying. Just subtract, see the differences between the case 1 value with case 2 value. If you calculate that, you will be end up in recovering the capital cost you invested for buying the new light and new fan in not more than 1.5 to 1.6 years. In just 1.5 years, you will be taking that money back. How you will be taking that money back means, earlier case, for example, if you are paying 100 rupees as your electricity bill because of that particular load, after replacing it with the energy efficient device, you are going to pay only the 50 rupees. So consider the 50 rupees saving every month. And if you keep on add, and you know what is the capital cost you invested for the product, and just see when it is getting break even. That break even usually happens in 1.5 to 1 year, 6 months, or 1 year, 7 months. This is a basic kind of cost analysis, basic kind of a business case that one should understand. And it is not about throwing out the old one and bringing a new one. It's all about how much efficiently we are using, how much we are reducing, how much we are saving, how much we are conserving. So that is the real objective behind that. Then appoint the management representative. Is about the guy who is going to manage. For example, a big factory is there, so that particular guy who is the energy manager. There are many courses also, energy auditors, energy managers. So these energy managers are very much concerned about how to manage the energy, how to inspect the devices. Let's say basically in the heating and cooling application, wherever the induction motor comes into the picture, the energy auditing is really needed, because of that process you can very easily can eliminate the losses of minimum 10% to the maximum 20%. Then you can establish the energy management team inside your premises. That energy management team will be very curious about implementing the systems of energy savings. Imagine in an educational institution, I think you all from the energy academic background, our classrooms have fans and light, and after 4 o'clock or 4:30, wherever the college, whatever the time the college ends, the students will go off, all the lights, fans will keep on run in the evening time. There is no one to check how to switch off that, who is going to take that responsibility. There are some clubs like energy clubs, clubs, and all these things in the colleges. They'll speak in that meeting, and the students will also rotate their heads, move their heads, say yes, I will do. And maybe more stickers are there near to the switchboard saying please switch off when there is no in use. But I don't think 100% is efficiently implemented. So basically, you can't believe humans in kind of accuracy. So the only solution is implementing the system. Just another example I'm giving, how to implement in your local premises. Put a motion sensor inside the classroom at the center. So whenever people are inside, the fan will run. Otherwise, the motion sensor will cut off the load of the fan. So when there is no people, automatically the fan will cut off. Just do a small calculation. Like if you do this kind of setup in a small one classroom, on an yearly, if you calculate how much you are saving, that figure is phenomenal. You can't imagine how much you are saving. So slowly these kind of things, and also switching off the light and lights in your outer environment in your college campus. Usually the lights will be put on by 5:30, and it will keep on glow even up to morning 7:30 sometimes. So you can put a timer instead of that. You can put a photo sensors instead of that. So how efficient? It's not necessarily that the light has to run for 12 to 12, dusk to dawn. Basically, it's not about 12 hours. It is from the dusk to dawn. So in summer, the dusk to dawn period will be less. In that particular 3 4 months also, you'll be saving energy. So energy management is something like bits and pieces of savings altogether, which is a big figure. If you add all together, consolidate and see, the kind of saving you incurred will be enormous. Let's see about the energy trends. So this is an annualized energy trend. If you see, this is a kind of consumption of electricity pattern and consumption of fuel with respect. It is the energy demand is going to be keep on increasing in the near future. There is no doubt about it. But are we having the energy management system? Are we having the energy utilization practices proper in place? If you ask the question, the answer is not yes. So basically, this process, this practice will only start if you practice this at your home. So start from your home, implement to your work environment, teach those two things to your students, propagate these things to your friends and networks and relatives, and tell them what is the kind of benefits they are going to incur about this by means of implementing this kind of systems. Then definitely one should be very happy about doing this. So this is the energy management cycle. So first is understanding the energy use. The next is planning how to do that. Third is implementation, doing that. Fourth is verification, monitoring, and reporting. Once you implement any system, you need to basically verify that. Is that working correctly? Is the data are occurred properly? Then monitor it. It is under the control, it is under the limits, it is under the reference values. Then it's not about only monitoring. Also, the data should be reported in a very presentable manner. One should be getting those data in a respective columns in a proper Excel sheets, or by means of a pie chart or bar graph in a kind of representation form. It's very easy to identify where we are going, what is the kind of consumption we have. The next is the company and commitment. So one can commit. There is a code called ECBC, Energy Conservation and Building Code, which has become a law actually. So any building which is having a higher build-up area, they are supposed to have this kind of energy management practices in their building infrastructure and architecture. So this is not a simple task. There are green buildings also in India. You can see a zero carbon, zero emission building, zero energy building, self-sufficient energy buildings. Like that, there are a lot of peoples, they have done their part as a pilot projects. You can just have a look on that. Now let's see what is energy conservation. So energy conservation is nothing but an effort made to reduce energy consumption. Simple. So the important concept is going for green energy system. Whatever we are speaking about energy conservation, energy management practices, you will be end up at a point that you can't do more than particular certain point. Imagine a factory, Apollo tire factory. In Apollo tire factory, they'll be emitting carbons into the atmosphere by means of the process as a end of a process. But to mitigate that, to adjust that carbon emissions, they'll be doing lot of carbon neutral activities like installing solar power plants, reducing the dependability of fossil fuel. They generate the electricity power from the solar panels, and they use it their purpose. They'll be implementing the solar water heaters. They'll be using the biomass, bioproducts for their applications, biodiesel for their DGs or whatever it is they use it in their premises, and whatever the possible ways there they can reduce their carbon footprints, they'll be implementing it. So that has some standards like ISO 14001, the environmental standards, and new codes are also there. So one must be very careful about how much he can able to save. Why it is important? Because without energy conservation, the world will deplete its natural resources. Definitely in a point of time we'll be end up in nothing. And we're not seeing this as an issue because it may many decades to happen. Once it is depleted, if you think that our coal resources are over, it is not possible to get it in the next matter of 10 or 15 years. It will take millions of years to get it again back. It is not at all possible, and we are not going to be there to that time to see that what is happening. And again, once you waste it, it is not possible enough, and it will take a lot of cost to recover that effect. And the final thing is the goal with energy conservation technique is to reduce the demand, protect, replenish the supplies, develop and use alternate energy sources. So importantly, wherever possible, you can able to bring an alternate energy source. Please try to bring in. It is definitely going to make a big change. The energy is not only limited to electricity, as we all from the speaking, the energy is basically a electricity perspective. So I'm just giving an example. It can be anything, like how we avoided the usage of kerosene to LPG. It is one of the energy conservation practices. Still, instead of using LPG, now we have shifted to induction based stoves. Now solar based cookers also there. Like that, many things are coming. So one should be always keep on seeking what is the best alternate that we can go for. This is the need of energy conservation in India, because our demand side up to 2500 megawatt electricity demand can be reduced just by means of going for energy conservation. And to reduce our energy demand up to 2.5 times demand is possible from the dependability of fossil fuels. In India's energy intensity per unit of GDP is higher as compared to Japan, US, and Asia by 3.7 times. You can see the figures, which really makes a big impact about what is the significance of energy conservation. And this is the practical methods for energy conservation. So first is install CFL lights if we have incandescent. If you have CFL, replace with LEDs. Lower the room temperature. For example, if you are having an air conditioner in your room, the comfortable temperature is somewhere around 23 to 25. There is no need to keep something around 16 to 18 degree. So that is one thing. And second thing, don't make any open windows. Don't open the doors all the time when the AC is running. Don't put too much of material inside the room. Try to vacate the room as much as possible when there is a AC is used, or try to lock the doors, try to put the cupboards in the compartments, so that there won't be any kind of absorption of the cooling effect in the other objects which is in the room. Then next, fix air leaks. Use maximum daylight as possible. Avoid the usage of lights. Get energy auditing done, because as an organization, especially in colleges, I don't think hardly 10% of the colleges is doing this. My voice is audible to you?
Yes, sir.
Yes, sir.
Okay, fine. The next is usage of energy efficient applications, appliances, then driveless work mode, then carpooling. These are all another ways of coming in the background of mobility. Then switch off appliances when not in use. Then plan shady landscaping. Then install energy efficient windows. Like I can see the concepts of green buildings after this session. There are many things. So basically, the architectural aspects comes in a very big way into the picture. So you have now double layered glass, triple layered glass, which can reduce the light intensity, which can control the temperature, which can make us an, which can actually partition your room, and also it can maintain a good temperature. So basically, one can reduce 30% of their total energy consumption by means of bringing the energy conservation practices. Other conservation techniques in the sectors like education, zero energy balance, alternate power, bringing into that, then cap and trade agreements, we can go ahead, then going for the reduced demand, and finally the research and development sector. So you can see the comparison of energy usage in the domestic sector. So the table fans will be consuming, ceiling fan will be consuming 26% of energy, fluorescent tubes 10%, refrigerator 10%, incandescent bulb is 9%, TV is 9%, air compressor is 9%, table fan is 9%, other miscellaneous are 9%. So this is your energy consumption pattern in your home. Just imagine if you could able to save instead of fluorescent by going for LED, there 5%, then going for a 5-star rated applications like in the fridge again 5%, then incandescent bulb replacement 5%. So if you think this is 100%, then after the conservation it will be only 70 to 75%. So possible ways by means of implementing this in the domestic sector is like conducting a periodic energy audit, selecting the energy efficient equipments, proper capacity. For example, if you have a bathroom in your home, it doesn't need a 9-watt light. Basically, a bathroom need only a basic light. There you can implement a 5-watt. If you have a hall, in that if you just put two tube lights, two fluorescent tube lights, it's probably no need. Put as one center light, a down light on the top, or a efficient 20-22 watts tube light at the center, which can effectively give the proper light for the particular place. Then proper ambient. So ventilation is important. For example, if you have something a heating fridge is there, and if you are keeping the fridge something near to the hot area, if you have some possibility to keep in a proper environment, proper temperature, please relocate that product to that environment, because the impact of temperature will definitely stimulate the electrical device to consume more power. Then good operation and good maintenance will definitely consume your conserve your power. This is the kind of energy savings which you can able to save by means of doing the conservation practices, by means of organized cooking. For example, if you are going to cook rice in a cooker, usually we put rice and water and put into the cooker. Imagine it will take 15 minutes. If you put the hot water while boiling the rice into the cooker, and if you put the stove on, you'll definitely make it in 8 to 9 minutes. It will not be 15 minutes. So the duration of 8 minutes, I mean the 6 to 7 minute savings of LPG is energy conservation. Then planned choice of quantity of water reduces the gas usage, on flame cooking, then usage of CFL LED lamps, planned ambiances, and proper maintenance. So altogether, you can see This is a kind of impact of energy savings one should save by means of doing this practice. I hope once this webinar is over, everyone kindly look into your applications in your home, appliances in your home. Think where and all you are overutilizing, wherever you are actually not monitoring, where and all it is consuming more. Kindly have a look. So first what we have seen is the domestic sector consumption. Now what you are seeing is the industrial sector consumption. So in the industrial sector, motor is a huge load. 25% is consumed by the motors, and pump, fans, air conditioner, refrigerator, fluorescent tubes, high pressure mercury vapor lamps, and sodium vapor lamps. So now this all the lamps is replaced with all the lamps is replaced with energy efficient LEDs. All the air conditioners which we are using nowadays is inverter ACs, which has a DC compressor. So there also we are saving phenomenal reduction. As an air conditioner, I just give an example. If you maintain temperature of 25 degrees Celsius for 4 people inside a room of a room size of 10 into 15 feet, which runs from morning 9 o'clock to evening 6 o'clock, a normal AC will be consuming 5.5 to 6 units of power. The same temperature for the same area for the same people, if you do with a inverter AC, you will be only incurring 4.5 units of power. So basically 1.5 units is saved for one AC for one day. Just imagine for a big institution where you are having huge number of AC, the saving will be phenomenal. This is a kind of process which has the possibility to reduce energy demand. It's like choosing a location and properly connected capacity, standard of machines and equipments. Sequence of operation also makes a sense. Not only that, like standard of machines and equipments, I'm just giving an example. If you see belt drives, where in a manufacturing industries, there are drives pulleys where you have a belt which will drive the system. If your belt is not actually fit firm enough, do you think what is the kind of loss it will make? It will be 15 to 20%. It will consume more power because of the loose belt, and also the shutdown of the system because of the belt failure will make you the lack of production for 1 day or 2 days. That is also a big loss. Then basically periodic calibration and maintenance will reduce its impacts, and obviously usage of latest state of technology, and wherever possible creating the awareness of energy conservation measures and audit can be practiced. I strongly feel just saying about save the energy doesn't works out. Basically one should make everyone to feel the kind of saving what they will incur, what they will enjoy. So once you show the kind of savings, kind of benefits which is going to enjoy, definitely people will know, okay, this is the kind of impact, this is the kind of savings I can enjoy. Then make them practice and convert that practice into an habit. So energy conservation is not a practice. I want to conclude, it should be a habit. And the third sector is the transport sector. The transport sector, the road transportation constitutes 67%, whereas air is 4, rail is 16, water is 13. So road transportation is the huge area where it consumes a lot of fossil fuels, petrol, diesel, gases. So one should be very, very keen on thinking the replacement of fossil fuels by bringing the electric vehicles. Not only the electric vehicles, also the energy efficient battery mechanisms, then energy storage mechanisms like fuel cells and advanced lithium polymer batteries, and other new technology which is coming on the place. One should call electric vehicle as a pure green energy transportation if the charge for the battery of the electric vehicle is also being charged from a green source. It may be from a solar or wind or from hydro. If you are charging your electric vehicle battery with conventional grid power, and if that grid power is coming from burning out of a fossil fuel, it is actually not a green transportation. You may think you are eliminating your carbon emission in the road, but you are again putting your carbon emissions in the thermal power plant. So this is the possible ways that you can do in a transport sector. The process involved a planned travel in teams to avoid wastage of fuel, practice of public transportation, then proper choice of mode based on persons, like if one person is go by scooter, if four people go by car, there is a group of people can go by bus or train. So like that you can plan. Again, it's all like there is something convenience. More than that, there is something future. If you feel more comfortable for yourself today, definitely you are reducing the comfortness of your child for the future. So please look into that. Then finally, the awareness of energy conservation measures and energy practices. And this is about commercial sector. The commercial sector lighting is 60%. So just think flat 30% can be reduced by means of implementing this. The next, heating and vaporizing. So as I told, preheating application can be adopted here. And this is the possible ways that you can do in the commercial sector. So giving the proper illumination, calculate the lux level. You have the softwares like Dialux. You can do the entire simulation of the lighting. Just see what is the kind of lux level I need in that particular place. Then accordingly you can use it. Then practice standard and efficient equipment process. Use eco-friendly controllers like intelligent smart controllers. Then obviously awareness. So I just conclude today's webinar on this energy management and implementation practice. Like energy conservation is not a practice, it should be a habit. Everyone should feel responsible on handling the energy, creating the energy, utilizing the energy, and conserving the energy for your future. So I hope you enjoyed the session. You take some topics, you share them, important observations. And I request everyone to immediately look after this webinar, like what are the old equipments in your home, around you, and your college. Just think, just do a cost analysis. If I replace that device with the new one, in how many years I'm going to get the break even? Propose that idea to your management, propose that idea to your family, try to replace it, try to save more energy in the long run. Thank you. Your questions are now open.
Dear participants, please type your questions in the chat box so that you can answer for your question.
No questions?
Yes, sir, because you have explained very nicely in a practical manner, so everyone enjoyed your session, sir, actually.
Thank you,
Sir?
but I expect minimum 2 to 3 questions.
Sir,
Yeah, please.
excuse me, sir. Sir,
Yeah.
I have a question. Can you
Yeah,
give
please.
us the solar kit details and price to make a house self-sustainable with energy free so that we can produce our own power
Definitely. You have
for
my
our
email ID.
day-to-day requirement? And
I hope you have my email ID. So just drop on me about your requirement. I will give all the necessary details in the mail.
is that possible, sir? Is that possible and there is no need to depend on TNE?
100%. I think someone voice is crossing. Who is it?
Now please proceed, sir.
Can you just ask the question again? I think someone has
Sir?
asked the question. Someone has
Yeah, it
asked
is
the
me.
question. Yeah, please ask.
Sir, can you give us some more information about the solar kit so that we can make our house self-sustainable with energy free to produce our own power for our day-to-day requirement and not to depend on TNEB?
Definitely, I can give you some idea about it. Basically, energy. If you take any home, the basic requirement will be one fan, two lights. So whenever we have a power cut, we are used to assemble in a place, and we put a fan there because we need a limited backup. And next thing is we have an essential. We should have an essential lighting. So one light will be on the kitchen, and one light will be on the bathroom, and another light will be on the hall or the bedroom where your peoples are there. So if you look very critically, the loads will be only this much. So the maximum power cut a person can experience in any of the place in Tamil Nadu will not be more than 5 to 6 hours. So you can very well can design a system which can handle a fan, two tube lights, one CFL, and a USB charger and your laptop for 5 hours in affordable cost. And that is also possible. It's not that you're supposed to go and buy a ready-made product. You can buy a controller, you can buy a battery, you can buy a solar panel, you can integrate that, you can connect your load in that. There is no harm. So you can just drop a mail or just ping me in the WhatsApp. There are some ready-made products of that particular requirement. I can share that to you. If it fits your requirement, you can go for it.
Thank you, sir.
So there is another question. There is another question, sir. Any software available for energy calculation, sir? It is asked by Veera Sundaram, sir.
I would say one thing like energy conservation. There is no, you have to do in a different platforms. Let's say in a solar power plant, if you do a shadow analysis calculation, that is one kind of energy management. If you take a building design, if you do the thermal analysis, that is one kind of energy conservation practices. There are softwares like green building softwares are there, where energy building energy simulation softwares are there. Maybe I can share that link to you. You can share those softwares. Few softwares will be on the trial. Some softwares are payable. You can do basically, you just calculate by bringing the natural light, by optimally utilizing the atmospheric temperature and the heat or cooling effect or the light effect, how much you can save in terms of electrical is the calculation. It can be used in 2-3 forms of softwares, and it has to be put together to see a consolidated report. There is no such kind of one single software which can talk about the complete areas of energy conservation. It has to be different softwares in the different domains, and all the energy conservation data has to be put it in a consolidated form, and that can be taken as a reference.
Thank you, sir. That's another question. Please tell about ISO 50001 standard.
ISO 50001.
Yes, sir.
This is you're asking for an industry or to be implemented in a academic institution?
Mr. Rajaram sir asked this. Rajaram sir is available there. Can you unmute yourself and can talk, sir?
Yeah.
Sir, good evening, sir.
Yeah,
this is Rajaram from Rajagopal Polytechnic College, Kudiyatham. Sir, actually, there is a good awareness about this ISO 9000 quality standard, 14,000 environment, and 18,000 occupational safety, like that. This 50,001, there's an energy conservation standard. There is not much awareness either in the industries or in the academic side. Actually, in industries also,
they'll be having the energy carbon commitment. So most of the big companies like JK Tires, Apollo, all the foundries like Ashok Leyland foundries, all the refineries, they are practicing that. but the
That
medium
breaks
level.
India. Sir, I hope this breaks India foundry in Schrödinger. They are having ISO 50001 standards
Yes.
actually.
Yeah.
But in India, many companies have to pick up because this Energy Conservation Act only designated consumers. It is compulsory for them to go for energy audit. For others, it is optional. Can you put some more enlightenment on this 50,001 standards?
No, 50,001 is one of the quality management standard from ISO. So basically, it is going to again involve all the things which we have discussed so far in a very detailed manner. Any company there, they will have some set of process, that process wherever possible, whatever the point of measurement techniques which you can able to adopt, it has to be adopted. There is nothing like the new thing which they are going to do. It's a strict management process which emphasizes to follow the energy management and energy audit process. That's all.
Okay, thank you, sir. One more question, sir. You are having a wide experience in installing so many solar projects actually.
Yeah.
This net metering facility, the government is giving for academic institutions, only government and aided actually. Why this private people, they are not entertaining that? This net metering facility.
Till March 2019, the academic institution who is coming under 2B2 tariff is not eligible for net metering. Before that, only 2B1 government aided and government aided educational institutions are only allowed for net metering. After April 2019, state government of Tamil Nadu have changed the policy of net metering to net feed-in. In earlier case, if you export 10 units as surplus to the grid, in your further import, the 10 units will be subtracted in your electricity bill accounting. But after the 2019 April, the accounting mechanism will be net feed-in. In this case, if you export 10 units, the cost of energy is considered at 70% of the APPC cost, which is almost 2.3 rupees per unit. So 10 units exported into 2.3 is 23 rupees. That 23 rupees will only be subtracted from your bill. It is not about 10 unit subtraction. So this is the change in terms of net metering accounting mechanism in Tamil Nadu. Next case, availability of meters. Before April 2019 or even up to say September 2019, the availability of meter is a bigger issue. After that, government has procured a set of meters, and also they have given an option. If you want to procure the meter outside from the approved vendors, you can buy, let's say from an L&T or from a Genus or from Echo, or it is. But that meter has to be again certified with MRT, meter relay testing of your particular O&M section, and that meter can be implemented in your place. So now it is not at all possible because the net metering process will also become online now. So one who wish to apply for solar net metering can directly go to TANGEDCO site. They can apply for the net metering. They can see the status of it. They can see the progress of it, and it can be implemented.
Thank you, sir.
Thank you very much, sir. Whether this net metering.
You are from which polytechnic?
Sir, I am from Rajagopal Polytechnic College, Kudiyatham, sir. Kudiyatham.
Okay.
Vellore, near Vellore.
Vellore.
Yeah, Vellore, sir. Whether this net metering facility is available for HT consumers also?
HT consumers are not eligible for net metering.
Oh.
HT consumers
then we have to get
HT consumers have to go for PPA only. They are not. It is given that a 1 megawatt consumer having a dedicated feeder can go for net metering. Maximum is 1 megawatt.
Okay. So whether we can get one more LT connection and we can connect a solar plant, no, sir? That is possible if HT is there.
What is the problem in that? You can go LT connection up to 110 kilowatt according to Tamil Nadu government. Up to 110 kilowatt is LT. Okay. So anything in the LT, anything less than 110 kilowatt, you can connect.
Okay. Thank you, sir. Thank you very much for your kind information. Thank you.
Thank you. And
Thank
what is
you,
the next
sir.
question?
Whether IoT based smart metering is available in industry for energy conservation.
Yes, yes, it is there. There are companies like Elmasher and many other companies like L&T is there. Then even Genus is there. And hello, can you hear
Yes,
me?
sir.
Yes, sir.
Audible.
Yeah, there are many companies like Elmasher, L&T, and many private peoples also doing. They are doing. It can be implemented very easily. Just putting in CT and PT. So you're just going to employ the current transformer and CT coil and PT coil and get the data, and it has to be acquired in a monitoring platform. But the critical thing is, if you further look into, if you want to only monitor the voltage, current, power, and energy, is not at all a problem. You can just go to the Amazon or Flipkart also. You can just type smart switch, Wi-Fi smart switch, Wi-Fi smart plug, or whatever it is there in that. For example, if you want to track your consumption of an AC, you can buy the device. It will 1,200 rupees. It will connect to your local internet, and it can connect to your mobile also. You will see what is the how many hours your AC has been run, how much energy is consumed, and also in the device you can schedule it. For example, night 10 o'clock it has to be switched on, 10 to 11 it has to be run, 11 to 11:30 it should be kept off, then 11:30 to 12:30 it should run. Like that you can schedule also. You can monitor how much of energy it is consumed also. Now the devices are already available.
Thank you, sir.
Yeah. What is the next question?
For doing energy management study for an educational institution, what is the starting step and any reference available, sir?
References can be many, but starting step is first identify your problem. First identify what is your biggest issue in your energy sector in your premises. Let's say I have too much of problems in my motor. I am facing frequent problems in my air conditioner. I'm facing too much frequent problem in my AC. I mean my MCB is tripping. My cables are burn out. Like that, there will be some kind of issues you'll be facing. And the ultimate issue is the highest electricity bill you are paying. And sometimes you will be you will be exceeding the maximum demand. So it can be anything. First, locate what is the problem you are facing from your electricity manager who is there in your campus. Then, based on their input, just completely take your electricity scheme, electricity consumption pattern, your nature of supply, kind of load connector, pattern of energy consumption, analyze it. Then, then only the kind of energy auditing process will start based on the problem area.
Yes, sir. Thank you, sir. I hope this is the last question, sir. Participants, I hope this is the last question.
Also, furthermore.
If you have any doubt, you can unmute your mic and you can ask question.
Yeah, what is the last question?
No, sir. No questions posted in the chat box, sir, till now.
No, I have seen some more questions also. 1 minute. For doing arrangement for education, what is the starting? Oh, that you asked.
Yes, sir.
Then, any other questions?
No, sir. I hope this is the last one.
Yeah, what is the last question?
No, that's what. Ended, sir.
It's over.
Yes,
Okay. So shall we conclude?
yes, sir. Yes, sir.
Okay. So I thank all the audience for staying in this session. It's a wonderful interactive from the audience also at the end. I hope you will take the better takeaways from this presentation and definitely will implement in your home and also in your work environment and make a self-sustainable world for the future. Thank you.
Thank you, sir. Good evening, everyone. I, Karkoli Subramani, on behalf of Management Department of EEE RMT Engineering College, I extend very hearty vote of thanks to Mr. Raja Ganesan, Director, Technical Operations, Vatio Energy India Private Limited, Chennai, for allotting his precious time with us for Day 4 Faculty Development Program on Energy Management Implementation Techniques and Energy Conservation Best Practices. He has given an elaborate session about benefits of energy management, practical methods of energy conservation. He also guided us some steps how to implement it in practical. He also shared how to make others to convince to practice these methods of reducing energy consumption. Thank you, sir, for your useful and informative speech. And you also created an awareness between our society, profession society. Thank you very much, sir. This speech will be useful for many participants, really. And I remember again your quote, if you want to enjoy the comfortness, then your child will not enjoy the same thing. It's very nice
Yes.
thing, sir. Sure, I will
Thank you.
accept this
Thank
also,
you
sir.
very much.
I'm
Thank
very
you very much.
thankful to, thank you, sir. I'm very much thankful to all the participants for their valuable presence here, and also they'll implement it, I hope. Thank you all. Thank you very much, sir. Tomorrow's session will start at 11 a.m. as usual. Kindly all the participants present by earliest around 10:45 a.m. to avoid the traffic. Thank you all. Thank you, sir.
Thank you. Thank you very much. Thank you all.
Thank you, sir.
So shall I leave the
Shall I
session?
end the meeting?
Yes, sir. Yes,
Yeah.
sir. Thanks a lot, sir. Very
Yeah.
informative
Thank
speech,
you.
sir. Thank you, sir.
Thank you. Bye.
Thank you, sir.